when we're looking at these, if you have an imaginary zero, its conjugate also works. Are any of those zeros imaginary? No. So are there any other zeros that I didn't give you? No. So if we're trying to come up with our polynomial, if negative 3 is a zero, what would I have to have in my factor form? If negative 2 is a zero, if 5 is a zero. I said degree 3, if I multiply this out, I have 3 x's, so we're good so far. But then I have one more requirement. F of negative 1 equals 6. We haven't seen one like that before. What that tells me is when my x is negative 1, y has to equal 6. I can't have any more x's in here because it's degree 3, I already have my 3 x's, but what we could have is some coefficient out in front. Could be a negative 5 or something out front. So we need to figure out what that number might be. What I'm going to do is just put an a there for now, and we're going to find a using this information. When my x is negative 2, so if I put in negative 1 for all my x's, this has to equal 6.
Got 36 minutes, stop.
Negative 1 plus 3 is 2. Negative 1 plus 2 is 1. Negative 1 minus 5 is negative 6. If I multiply that all together, negative 12a equals 6. Divided by negative 12, so my a is negative 1/2. So we had that extra requirement, gave us one particular point that had to be on our graph. So we had to figure out what that made our coefficient. So my actual polynomial is negative 1/2 times x plus 3, x plus 2, x minus 5. So if we do another one. 4 is a zero of multiplicity 3. What does that mean?
That'll be 4 times 3.
So if 4 is a zero, that means it gives us x minus 4. And multiplicity 3, we have it 3 times, or we could just say to the 3rd power. Okay, that's my degree 3 that we needed. And then I'm telling you f of 2 is negative 24. So we know there could be some number in front. We need to find it. So if we put in a 2 for our x, that's negative 24. Negative 2 to the 3rd is negative 8. Divided by negative 8, and our a is 3. So our polynomial has to be 3 times x minus 4 to the 3rd. That meets all the requirements that I gave you. Are there any questions on those?
I don't understand what we need after we get the x minus 4 cubed.
We had an extra requirement. I have told you that also, when you plug in 2, it has to equal negative 24. If I just put it in here, if I put in 2, I get negative 8. It's not negative 24. So this polynomial doesn't meet all the requirements. We can't have any more x's because at the beginning I already told you the degree was 3, so there's only 3 x's. So the only other thing we could do is multiply it by a number. So we are finding out what number do we have to multiply it by to make f of 2 equal negative 24. Other questions? Alright. So what we ended yesterday with was writing a polynomial with some imaginary zeros. We did some more today writing polynomials, but I'm giving you information to find a coefficient. I want to go back to that idea of imaginary zeros. So we have done problems similar to this, where I would give you the first 0 and you had to find the rest. And so what you did when I gave you the first 0, we had to divide by it so that we would get a polynomial we could factor. We're doing that same thing now, but I'm telling you that I want all complex zeros. When I say complex, that means they could be real, they could be imaginary. And the first 0 that I gave you is actually imaginary. So it's the exact same thing. I'm giving you the first 0, so what do we have to do? Division. But I'm dividing by an imaginary, so you might need to space these out a little bit more. So my 3i is the 0, so it's what goes here. My coefficients, just space them out a little bit more than you're used to. And we're going to do synthetic division with this. Okay, synthetic division. The first number always just comes straight down. Then we multiply. 1 times 3i is 3i. Add negative 1 plus 3i. They are not like terms, so I have to keep them both. Okay, we're back to the multiplying step. If you need to, you can go out to the side or the margin and kind of think about this. We are taking 3i times this. So if you distribute it, you get negative 3i plus 9i squared. What's 9i squared equal to? I squared is negative 1, so 9i squared is negative 9. Right, when I add, we're adding like terms. So I can do 10 plus negative 9, that's a 1. And we still have the minus 3i. Okay. Multiply. So we have to do 3i times the 1 minus 3i. So 3i times 1 is 3i. 3i times negative 3i is negative 9i squared. So I have 3i. What's negative 9i squared? Now when I add like terms, negative 9 and positive 9 cancel, and we just get 3i. So multiply, we have to do 3i times 3i, which is 9i squared, and that's equal to 9. And negative 9 plus 9 is 0. And I know this has to be 0 because I told you 3i is a 0. Okay, if you get anything else there, you've made a mistake. Now normally at this point we wrote it as a polynomial and factored. This is my constant, this would be x, x squared, and x cubed. But the problem is, do we know how to factor something with an imaginary coefficient and an x squared? No. So if I just try to jump into factoring right now, it's not going to help me. What else do I know? If 3i is a 0, what else is a 0? Negative 3i would also be a 0. So I'm going to do synthetic division one more time. I am going to take the answer I just got and divide by negative 3. Okay, so this was my remainder. We don't need it, but we take these other coefficients. The 1, negative 1 plus 3i, 1 minus 3i, and 3i. And what should happen this time is all these i's should cancel out. Okay, so I gave you the first 0, but because it was imaginary, we know a second one. And so since I know 2 zeros, we divide twice. So 1 comes down. 1 times negative 3i is negative 3i. Add like terms, 3i and negative 3i cancel, and we just have negative 1 left. Negative 1 times negative 3i is positive 3i. Add like terms, negative 3i, positive 3i cancel, and we just get 1. 1 times negative 3i is negative 3i. Add those and we get 0. Have I lost anything? This is my remainder, constant x and x squared. So my problem is now x squared minus x plus 1. My directions were to find all the zeros. So does this factor nicely? Same thing, multiply 1, add to negative 1. So if you can't factor it, what do we do? So the opposite of b would be a positive 1 plus or minus the square root of b squared minus 4ac all over 2a. This will give me a 1 minus 4 or negative 3 under my square root. Square root of negative 3 would be I radical 3 over 2. So my zeros. Imaginary numbers, we typically split that up, so we'd say 1/2 plus and minus I radical 3 over 2. I asked you for all zeros here, not just the remaining ones, all of them. This is 2 of them. 1/2 plus that, 1/2 minus that. It was originally an x to the 4th, so we know we have 4 total zeros. What are my other 2? Positive and negative 3i. So this one, all of my zeros were imaginary. And I don't care if you put plus or minus or if you list them separately. Either is fine. Let's try another one of those. So again, I'm asking for all the zeros. How many are we going to have? 4. Whatever the degree is how many zeros. So it's an x to the 4th. So there will be 4 total zeros. I gave you 1. We need to find the rest. So where do we begin? The first synthetic division is always going to be the longest, so that's one you might want to space out a little bit. Be careful. I go from x to the 4th to x squared. So remember, if you don't have power back, you put a 0. So 1x to the 4th, 0x cubed, 3x squared, 0x, and negative 4. First number comes all the way down. So the 1 comes down. Then we multiply. So 1 times negative 2i negative 2i. 0 plus negative 2i is negative 2i. When I multiply, I get 4i squared, which is negative 4. 3 plus negative 4. Multiply. Negative 1 times negative 2i is positive 2i. 0 plus 2i is 2i. Multiply. 2i times negative 2i is negative 4i squared, which is positive 4. Add and we get 0. Now remember, this is my remainder, which we needed a 0. Constant x squared, x cubed. This is not something we can easily factor in. So what do we need to do? Divide again, this time by positive 2i, the conjugate. And we take our answer here. That's what we're dividing, without the remainder. So 1, negative 2i, negative 1 positive 2i. Alright, this time the synthetic division should be pretty nice because all the i's should cancel. So 1 comes down. 1 times 2i is 2i. Negative 2i plus 2i is 0. 0 times 2i is 2i. Is not 2i. What is 0 times 2i? 0. Negative 1 plus 0 is negative 1. Negative 1 times 2i is negative 2i. And that adds up to 0. So we have remainder, constant x, and x squared. So this is just x squared minus 1. And that can factor into so this time I asked for all the zeros. So we have positive and negative 2i and positive and negative 1. Those are my 4 zeros like we predicted at the beginning. So, same thing that we were doing back when we had only real numbers. It's just we have some i's in our synthetic, so you'll end up doing it twice every time. Once with the 0 given and once with the conjugate, if the first one is an imaginary. Are there questions on that? Do we need another problem like this? So let's do, I think, one final example for today. Tomorrow we're going to start graphing. Today we're really just focusing on these imaginaries and kind of practicing the skills we already have. So if I give you a factored form, can you find the zeros and multiplicities from there? So my zeros, what's the difference between zeros and factors?
Different sign.
Okay. There are different signs, and the factors have the x with it, the 0 is just the number, right? So if we look at all these things being multiplied, a 0 is just what makes each of them equal 0. What makes 3x equal 0? Can you guys solve that? Just divide by 3, and we get 0. Okay, look at the next parenthesis. What makes 4x minus 5 equal 0? 5/4. Now, that one was different. It had a cube on it. What does that cube mean? Yes. So 5/4 is a 0 3 times. We write that as M3. If I said x squared plus 3 equals 0, x squared is equal to -3. How do you get rid of a square? Square root. When you do a square root, you have to add plus and minus. So we get x to equal plus or minus. The square root of -3 would be I radical 3. So you can write it as plus or minus, or I'm just going to separate so we realize those are two different things. We have I radical 3 and negative I radical 3. But what else do we have to consider on that one? What's that fifth power tell me? So each of those zeros have a multiplicity of 5. All right, do you remember, it was the very first day of this chapter, we talked about how multiplicity will affect the graph. If it's an even multiplicity, what happens on the graph? It bounces. Odd multiplicities go through. So that's why the multiplicity is important, and we'll be using that more tomorrow when we actually start graphing these things. All right, any questions there? So, a couple things I want you to do. I'm going to put a slide up that we're starting with tomorrow, and all I want you to do is write it down. We're just going to get that in our notes so we have a little more time tomorrow to talk about it. And then your assignment is a handout posted on Google Classroom. It's not super long, so we should have plenty of time to work on that. And I will also hand back those papers that you did in class yesterday and see if you have any questions. So, I just want you to write this down. These are all the steps we're going to go through when we graph our polynomial, so you have it in your notes.